Section 4.6, number 12. We're given any rational numbers a and b not 0, and an irrational number I, and we want to prove that a plus b times r is irrational. So we're using a proof by contradiction, and we say, let's suppose that it is rational. Let's see if we can get a contradiction. Well, if it's rational, then a, b, and this are rational. So we have integers that I'll call k, l, m, n, p, q, such that a can be written as a fraction, b a fraction, and a plus b are a fraction as well. And these denominators are not 0, as well as because b is not 0, b's numerator isn't 0 either, so m as well. Now we simply simplify a plus b times r, plugging in everything and simplifying this a little bit. So on the left, a plus b times r is p over q, and I have these fractions on the right, times r, and now I'm simply solving for r. So I move everything that doesn't have an r to one side, put them together, divide by the coefficient of r. Whoops, let me move up here a little bit. Put everything together, divide by m over n, and I get this. So now what do I see here? The numerator is simply multiplication and subtraction in combination of integers, so that's an integer. The denominator is an integer as well, and not 0, because neither one of these is 0. And we conclude, therefore, that r is a rational number, but that's a contradiction, because it was given that it is not. So we have no choice but to conclude that a plus br is not a rational number.